Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about solving systems of three equations with substitution.
Minute Math, when you need help you use Minute Math.
We're given this problem right here. Negative x minus y minus 3z equals a negative 9. Z equals negative 3x minus 1, and x equals 5y minus z plus 23, and we want to solve the system by substitution. First thing I'm looking at here, I see we have a z by itself already, and it's equal to one variable, the x, or something in terms of x. So what I'm going to do is actually take the third equation here, and then for z, I'm going to put in negative 3x minus 1. So let's go do that. I'm going to rewrite this third equation right here, x equals 5y minus, and instead of z, I'm putting that 3x minus 1 in for that z that's right there. You're going to see that here. And then we plus 23. Now let's simplify this as, well, much as possible. Okay? We want to get our like terms together. We want the x's to the left, numbers to the right. So we're coming down here, x comes down, we have the 5y. And then this negative sign, let's distribute. Negative times negative 3x is a positive 3x. Negative times negative 1, positive 1. And then we have plus 23. All right. I'm going to subtract the 3x to both sides, and that gives me a negative 2x here, equals 5y. Then 1 plus 23 is a 24. If I divide both sides by a negative 2, has good old parts. Now I have x completely by itself, and in fraction form we have a negative 5 halves, y, and then 24 divided by negative 2 is a negative 12. So now we have x by itself in terms of y, but where can we go from here? Well, what I'm going to do now is we want to get this z in terms of y. So I'm going to take that equation for z up here. Again, z equals negative 3, and instead of x, I'm going to put this in terms of y. So we're trying to find x in terms of y and z in terms of y here, and then we'll be able to substitute that in later to finally get y by itself. So negative 3 is right in front of the x, and then instead of x, I'm putting this negative 5 halves y minus 12 in. Then we have a minus 1. So see how it's the same equation here, but instead of x, I have what I've also found, x in terms of y. Now we want to simplify this, okay? Well, z is by itself again. Distribute the negative 3 to both parts. Negative 3 times negative 5 halves is a positive 15 halves, y. Negative 3 times a negative 12 is a positive 36, and we have a minus 1. Simplify it a little bit. 15 halves stays there, y, and then 36 minus 1 is 35. So now we have z in terms of y and x in terms of y. We can now go get y by itself now. So what we're going to do is take the first equation right here, so if you can see a little crisscross here, we're going to write this equation, but instead of x, I'm putting this equation on here we found for x in terms of y. Negative 5 halves, y minus 12. Then we have minus here, y. And instead of y, y is the variable we're looking for, so y stays there actually. So minus y, minus 3 times our z value, which we found here, 15 halves, y plus 35, and that equals a negative 9. So I know this equation looks pretty crazy right now, but look, there's only one variable, y, meaning that we can solve for that y. So let's go for it. Distribute the negative sign here to both parts, and we have a positive 5 halves, y plus 12. Then we still have a minus y here. Distribute the 3 times the 15 halves, and we have a negative or minus 45 halves. Don't forget to distribute the minus sign. Distribute the minus sign again. Negative 3 times 35 is a negative 105, and that equals a negative 9. All right. So now we want to combine our, well, like terms here. Oh, this is y. Oops, 45. See, I know I was going to forget something. Negative 45 halves y. If you caught that, let me know down below. So now we want to combine our like terms. Notice here that this minus y doesn't have a 2 in the denominator, but these two do. So to kind of see that, if you want to put a minus sign here, 1 is the same as 2 over 2. Now it's a little easier to see we can add our like terms y's. Okay, 5 halves minus 2 halves, which is 1, minus 45 halves comes out to be a negative 42 halves y. Then 12 minus 105 is a minus 93, and that equals negative 9. We added 93 to, added 93 to both sides. That's my next step, and then 84. And 2 goes into 42, it goes 21 times, so we have a negative 21y here. Divide negative 21 to both sides, and y equals a negative 4. After all that, we got one of our y values. All right, but now this is actually the easy part. We can get our x values and z value here. So let's go with the x value first. Since y equals negative 4, we can take this equation that we simplified and put negative 4 in for y. So x equals negative 5 halves times a negative 4 minus 12. And let's simplify. Negative 5 halves times negative 4 is a positive 20 over 2 minus 12. And 20 over 2 is 10 minus 12. X equals a negative 2 here. So we have x, we have y, let's go find z. Well, z by itself is right here. So we have z equals a negative 3, and we found what x equals now, negative 2 minus 1. Now we solve again for z. Simplify that out. Negative 3 times negative 2 is a positive 6 minus 1, and z equals 5. And so we have our three answers. We can put as a coordinate point negative 2, negative 4, and positive 5. And that's our final answer. X is equal to negative 2, y is equal to negative 4, and z is equal to 5. We're given this problem right here. X equals a negative 4z minus 19, y equals 5x plus z minus 4, and negative 5y minus z equals 25. And we want to solve this system by substitution. The first thing I'm looking at here actually is I'm going to look at this y equals 5x plus z minus 4. And the reason I'm looking at that because I know I can substitute this x in, and now I have y equal to just z's. Okay, putting that this negative 4z minus 19 in for that x. So let's do that. We have y equals 5, and instead of x, we're going to put this value, negative 4z minus 19. Then we add a z to it, and we have a minus 4. So then from here, we want to simplify to get y by itself, or as much as possible, to simplify, but keep y by itself. So y equals, 5 times negative 4z is a negative 20z, and then 5 times the negative 19 is a negative 95. And then we have plus z and a minus 4. Well, let's combine our like terms here. Negative 20z plus 1z is a negative 19z. Negative 95 minus 4 is a negative 99. And I'm done with this equation for the moment. What now I want to do is, well, I want to see if I can get a variable by itself. Okay? And we notice here on the third equation, I have y and a z. Okay, that's it. And this equation we found just has a y and a z as well. So what I'm going to do is take this equation we just found and plug it in for that y right here. So we have a negative 5 here, and instead of y, I'm putting this whole equation we just found, negative 19 z minus 99. Then we have our minus z here equals a positive 25. And the point of this, you can see that z is the only variable in this equation, and now we can solve. So let's distribute the negative 5 to both parts. Negative 5 times negative 19z is 95z. Negative 5 times negative 99 is a positive 495. And then we just have a minus z here, and that's equal to 25. From there, we want to simplify combining our like terms. So if we add or subtract actually a 495 to the other side, we get a 25 minus 495 is a negative 470. What was a 7? Negative 470. And 95z minus 1z is a 94z. Divide both sides by 94, and z equals a negative 5. And we have our first variable answer. Z is negative 5. So where can we go from here? Well, I try to find the easiest way to substitute it in. And right here we already have an equation. Right, let's just continue that out. We're just going back here. And z is negative 5, let's put that in. So y equals negative 19 times z, which is negative 5, now that we found minus 99. Keep going, let's just simplify. So y equals negative 19 times the negative 5 is a positive 95. Then we subtracted 99 to that. So here we have 95 minus 99 is a negative 4, and we have our y value. Y equals negative 4. So let's go find our x value. Well, our first equation here we can use. It only has y equals a part that's equal to, has a z in it. So let's rewrite that. X equals a negative 4, but instead of z, we're going to put a negative 5 in. And then we have minus 19. Simplify that out. X equals negative 4 times negative 5 is a positive 20 minus 19. And 20 minus 19 is a positive 1. And so we have x equals a positive 1 right here. And there's our answers. We can write it as a coordinate point. 1, comma, negative 4, comma, negative 5. And that's it. That's our final answer. X is 1, y is negative 4, and z is negative 5. We're given this problem right here. Y equals x plus z plus 5. Z equals negative 3y minus 3. And 2x minus y equals a negative 4. And we need to solve the system by substitution. Well, first thing I want to do is I'm going to look and see, kind of map out what I'm going to do. And I see my first equation here has y equals x and a z. And the second equation has a z equals something with y. So I'm going to substitute the z in here, or this negative 3y minus 3 in for this z, and I'll have an equation with just x's and y's. So we have y equals, and we have x minus, plus, and now we're inserting the z value. Negative 3y minus 3, and then we have plus a 5. And so now I'm going to simplify this, and I'm actually going to get x by itself, and you'll see why in a minute. So we have y here equals x, and we have a minus 3y minus 3 plus 5. All right. Now let's combine our like terms where we can. Okay. I'm going to add a 3y to both sides. So by doing that, add a 3y to both sides, I have 4y equals x, and then minus 3 plus 5 is a positive 2. And the reason why I'm going to solve for x here is I know I can easily just get x by itself without fractions, and I usually stumble up when there's fractions. So if I can avoid it, if I recognize it, I'm going to try it. So subtract 2 to both sides, and we have 4y minus 2 equals x, and we have an x by itself now. And that's going to help me, because now I'm going to use this third equation, okay, my third equation, and I'm going to put this x in here. And now we will have an equation with only y's. So the third equation, 2, and instead of x, I'm putting 4y that we just found minus 2 in. Then we have minus y equals a negative 4. And now I want to solve for y. Distribute the 2 to both parts, and we have 8y minus 4 minus y equals a negative 4. Combine our like terms. 8y minus y is a 7y. We add a 4 to both sides, and that equals, well, 0, right? Add a 4, we get a 0. Divide both sides by 7, and y equals 0. That's always nice. So we have y equals 0 here. And with that information, we can easily solve for x here, right? So we're going to take y equals 0, go back to this equation, and put 0 in for y. So 4 times 0 minus 2 equals x. Well, 4 times 0 is 0, so we're going to write here x equals a negative 2. And we're almost done. We now use that 0 again for the, well, second equation to get z. So we take z equals a negative 3, and instead of y, we put a 0, and we minus 3 here. Negative 3 times 0 is 0, so we just have z equals a negative 3. And now we have our three answers. We can write as a coordinate point, negative 2, comma 0, comma negative 3. And there we have our final answer. X is negative 2, y is 0, and z is negative 3. We're given this problem right here. Negative 2y plus 5z equals a negative 3. Y equals negative 5x minus 4z minus 5. X equals 4z plus 4. And we want to solve the system by substitution. First thing I'm looking at here is my second and last equation here. I'm going to plug this x value being 4z plus 4, and for this one, and I have y in terms of z now. So let's do that. We take the second equation, y equals a negative 5, and instead of x, I'm putting this, 4z plus 4m. Then we have minus 4z minus 5. Then from there, we're going to simplify this, combine the like terms, and y equals, well, distribute the negative 5. Negative 5 times 4z is a negative 20z. And negative 5 times 4 is a negative 20. We minus the 4z here and minus the 5. We now want to combine our like terms. Negative 20z minus 4z is a negative 24z. Negative 20 minus 5 is a negative 25. So now we have y in terms of z, but where can we go from here? Our first equation has y's and z's in it. That's it. There are only two variables. So I'm going to take this equation for y and plug it in here. And that will get us an equation with only z's. So we take a negative 2, and instead of y, we put in this whole negative 24, z minus 25, and then we have plus 5z equals a negative 3. Then what we want to do is simplify and solve for z. Negative 2 times negative 24z is a 48z, and negative 2 times the negative 25 is a positive 50. We have a 5z here, and a negative 3. We now want to combine our like terms. 48z, or let's subtract a 50 actually to both sides here, and negative 3 minus 50 is a negative 53. 48z plus the 5z is a 53z. Look how that works out. Now we can divide both sides by 53, and z is by itself, and negative 53 divided by 53 is just a negative 1. That's nice. So then from there, I'm going to take that negative 1, let's put it in for this z, and we can get y by itself. So y equals a negative 24, put a negative 1 in for z, minus 25. Well, y equals negative 24 times negative 1 is a positive 24, minus 25, and y equals 24 minus 25, again, is a negative 1. Two negative 1s here. So now we have to find x. Well, luckily we have x already in terms of z. So we have x equals 4 times z, which is a negative 1, and plus a 4 here. And now, pretty easy to solve. 4 times negative 1 is a negative 4, plus 4. Negative 4 times 4, or plus 4 is a 0. Not times, plus is 0. So we have our three answers. We can write as a coordinate point, 0, negative 1, negative 1. And that's our final answer. X is 0, y is negative 1, and z is negative 1. We're given this problem right here. Y equals x plus 4z minus 5, 4x plus 3y minus 2z equals 5, and z equals negative 2x plus 2. And we want to solve this system by substitution. Well, the first thing I'm looking at here is, well, I want to get, well, y, so you have y in terms of x and z, and I have z by itself. So I'm going to take that first equation here, y equals x plus 4, and instead of z, I'm going to put what we have here with z, negative 2x plus 2, and we minus 5 there, okay? Then, from there, I want to simplify to get, well, y by itself. So y equals, we have the x here, but we distribute the 4. 4 times negative 2x is a negative 8x, and 4 times 2 is 8. Then we have a minus 5 here. From there, we want to keep going. Let's get our like terms together. So y equals x minus 8x is a negative 7x. And 8 minus 5 is 3. So we have y equals negative 7x plus 3 here. All right? Now it gets a little tricky. I'm going to look at my second equation. I have y in terms of x, and I have z in terms of x. I'm going to plug both of those into my second equation. So we have 4x, the second equation here, plus 3, and instead of y, I'm putting negative 7, x plus 3. That's a 7, whoops, 7x plus 3. And then we have minus 2 times z, which is negative 2x plus 2. And that's equal to 5. Now don't be afraid, this is a large equation, but what's happy, or where the goal is, makes us happy, is we only have x's in it. So we know we can simplify this and get x by itself. So let's bring down and simplify, take it little steps at a time. 4x comes down, distribute the 3. 3 times negative 7x is a negative 21x. 3 times the 3 is a 9. And then we have minus 2 times minus 2x is a positive 4x. And minus 2 times 2 is a negative 4. And that's equal to 5. All right? All these steps here. So let's combine our like terms where we can. Okay? 4x minus 21x plus a 4x equals a negative 13x. So we have negative 13x here. 9 minus 4 is 5. And equals 5. Okay? Subtract 5 to both sides, and a negative 13x is equal to 0 after all of that. Negative 13 can be divided by to both sides, and x is by itself, and 0 divided by negative 13 is 0. So again, after all this, x just equals 0. That's nice. That makes the rest of it pretty easy. We take this x equals 0, we put in for this x here to get y by itself. So y equals negative 7 times 0 plus 3. And then y equals, well, negative 7 times 0 is 0. And we just have a 3 left over. And so y equals 3. Well, we have x, we have y. Let's go find our z. Our equation for z they gave us was z equals a negative 2. And instead of x, let's put 0 in. 0 plus 2. And, well, this is easy now. Negative 2 times 0 is 0. Plus 2 is 2. So z equals 2. So we can write the coordinate point 0 for x, 3 for y, and z is 2. And again, that's our final answer. X equals 0, y equals 3, and z equals 2. We're given this problem right here. X equals 3y minus 3z plus 8. Z equals 4x plus 5y minus 14. And 3y plus 2z equals 14. And we want to solve the system by substitution. First thing I'm looking at is I have z here by itself, and it's equal in terms of x and y. This x is in terms of y and z. So if I combine the two, I just have an equation now in terms of z's and y's. So second equation, z equals, I'm using blue, my other marker was dying. Z equals, well, 4. And instead of x, I'm going to put in this whole big top equation. 3y minus 3z plus 8. Then we have plus a 5y minus 14. Woof. Let's simplify this. So z equals 4 times 3y is a 12y. 4 times a minus 3z is a minus 12z. And 4 times an 8 is a 32. And we bring down the 5y minus 14. From there, let's combine our like terms where we can. Okay, so z by itself here, and we have, well, what can we combine here? Okay, we have 12y and a 5y. 12y and 5y give us a 17y. And negative 12z is the only z one on this side, so let's keep that here, negative 12z. And last we have our numbers 32 and minus 14, and that comes out to be an 18. Okay. Well, let's bring the z over. I'm going to get y by itself. So let's bring z over here, and we have 0 equals a 17y, and then we subtract a z, we have minus 13z plus 18. We then can subtract a 17y to both sides, so we have negative 17y equals a negative 13z plus 18. And dividing both sides by negative 17, y is completely by itself here. And negative 13 divided by negative 17 makes it a positive, so we have positive 13/17, z, not 7, z, minus, oh, this is 18, whoops, messed up there, minus 18 over 17. All right, so we have y by itself. It's kind of a gnarly equation, but we gotta keep going. So then we look at our third equation here, okay, and we plug this y in for this y here, and we have an equation with only z's. So we take 3, and instead of y, we put that whole equation we just found, 13 over 17, z minus 18 over 17. Then we plus a 2z here equals 14. And now we have to solve for z, or we can, and we're going to do it. Multiply 3 to both parts here, and 3 times 13 over 17 is 39 over 17. Z minus 3 times 18 is 54 over 17. And then we have plus a 2z equals a 14. From there, we want to, combine our like terms where we can, and we're going to rearrange this and add them together. So 39 over 17z, and I bring this 2z over, and 2z in terms of the same fraction, it's the same thing as 34 over 17z. Then, make sure I follow my notes here correctly, and we have minus a 54 over 17 here equals 14 in terms of 17 is 238 over 17. So now from there, let's combine our like terms. 39 over 17z plus 34 over 17z is 73 over 17z. And then we add a 54 over 17 to both sides, and we have a 292 over 17 here. All right, now we can multiply both sides by 17. They cancel out, so we have 73z equals 292. Then divide both sides by 73, and z is now by itself, and 292 divided by 73 is good old 4. After all of that, isn't that nice? Well, sometimes when it becomes a nice, neat answer, you kind of know that you did it right. All right, we have z by itself as 4, but we can use this equation here to get y by itself, or get the answer for y. So we have y equals 13 over 17 times z, which is 4, minus 18 over 17. 13 over 17 times 4 is a 52 over 17, and we minus 18 over 17 here. 52 over 17 minus 18 over 17 is a 34 over 17, and 34 over 17 is equal to 2. So we have y equals 2 now, z equals 4. Let's go find our x. And that involves the first equation here. We have x equals, okay, and I'm going to plug in, 2 for y. So we have 3 times 2. Again, that first equation right here. 3 times 2 minus 3 times our z value, which is 4, plus 8. Okay? So let's simplify where we can here. X equals 3 times 2 is 6. 3 times 4 is 12, minus 12 plus 8. Combining all that together, x minus 12 plus 8 is a positive 2. So we can write this as a coordinate point here, as x is 2, y is 2, and z is 4. And there we have our final answer. X is 2, y is 2, and z is 4. We're given this problem right here. Negative 5x minus 3y plus z equals negative 4. Negative 2x minus 2y plus 2z equals 4. And z equals x plus 5. And we need to solve the system by substitution. Well, let's look at our second equation here. My second equation, negative 2x minus 2y, right, plus, and instead of z, I have this as x, or z in terms of x, so let's put that x plus 5 in for that z value, and that's equal to 4. I'm substituting that in. And let's go simplify this. So we got our y's and x's separated. So we go down, we have negative 2x here minus 2y plus, distribute the 2, and we have 2x here plus 2 times 5 is 10 equals 4. Well, Now combining like terms, negative 2x plus 2x cancels each other out. So we just have a negative 2y here plus 10 equals 4, and we actually can get y by itself now. Subtract a 10 to both sides, and we have negative 2y equals a negative 6. Divide both sides by negative 2, and y equals a positive 3. So we have y equals a positive 3 here. Then from there, what we want to do is, okay, we have y equals positive 3. Let's look at our first equation, and let's put that y equals 3 in for this y right here. So we have negative 5x minus 3 times a positive 3, and now watch this. Instead of z, we put the third equation in, x plus 5, and keep going, equals a negative 4. And now we have an equation only with x's, so we can simplify this or solve it to get x by itself. So negative 5x comes down, negative 3 times 3 is a negative 9, plus x plus 5 equals negative 4. All right, let's combine our like terms here. Negative 5x plus 1x is a negative 4x. Negative 9 plus 5 is a negative 4, equals a negative 4 here. Add a 4 to both sides, and negative 4x here equals, well, 0. Divide both sides by negative 4, and x equals 0. Well, that's nice. We have x equals 0 and y equals 3. We need to get z. That's actually super easy. Z is right here. Z equals, well, instead of x, let's put a 0 in, plus 5. And so pretty much there, z equals a positive 5. We can write this as a coordinate point. We have all three down. 0, 3, 5. And that's our final answer. X is equal to 0, y is equal to 3, and z is equal to 5. We're given this problem right here. Negative 4x plus 2z equals 14. Y equals x plus z plus 12. And negative 2x minus 4z equals 22. And we want to solve the system by substitution. One thing I noticed about the, well, last equation, let's rewrite that here. Negative 2x minus 4z equals 22. If I pull out a, well, negative 2 from both parts here, negative 2, I'm left with a positive x plus a 2z here is equal to 22. I now can divide negative 2 to both sides, and x plus a 2z equals a negative 11. From there, I get x by itself, subtract a 2z to both sides, and x equals a negative 11 minus 2z. Well, where can that be helpful? Let's look at our first equation. Our first equation is in terms of x and z's, and we can substitute that in. So we have negative 4, but instead of x, I'm going to put a negative 11 in, that we just found, minus 2z. So you can see that right here. Plus a 2z equals 14. And now we have all the information we need to solve for z. Distribute the negative 4 to both parts. Negative 4 times negative 11 is a positive 44. Negative 4 times a minus 2z is a positive 8z. Plus a 2z equals 14. Well, combine our like terms. We have 8z plus a 2z is a 10z. We subtract a 44 to both sides, and we have a negative 14 minus 44 is a negative 30. Divide both sides by 10, and z equals a negative 3. All right, we got one of our values. Well, we can use that z equals negative 3, put it in here to find, well, our x value. So x equals a negative 11 minus 2 times a negative 3. And then simplify negative 11. Negative 2 times negative 3 is a positive 6. Negative 11 plus 6, x equals a negative 5 right there. So we have x equals negative 5, z equals negative 3. Let's find our y. Well, let's look at the second equation. Y is already by itself. So y equals, and for x, let's put negative 5 in. And for z, we put a negative 3 in. And then plus 12, and let's simplify that. Well, y equals negative 5 plus negative 3 is negative 8 plus 12. And negative 8 plus 12 is a positive 4. So we can write this as a coordinate point of negative 5, 4, and negative 3. And so our final answer here is x equals a negative 5, y equals 4, and z equals a negative 3. We're given this problem right here. 3x minus 3y equals a negative 6. Z equals a negative 3x minus 3y plus 9. And negative 4x plus 5y plus z equals 8. And we need to solve the system by substitution. First thing is, I'm going to look at this first equation here. 3x minus 3y equals a negative 6. I'm going to try to get x by itself. So I can pull out a 3 from both parts here, and I'm left with an x minus y equals a negative 6. By dividing 3 to both sides, I now have x minus y by itself equals negative 6 divided by 3, which is a negative 2. From there, I added y to both sides, and x is now by itself, and it's equal to a negative 2 plus y. Okay, so we have x in terms of y. Let's try to get z in terms of y. So our second equation right here, let's rewrite it down here, is, well, z equals a negative 3, and instead of x, I'm going to use the x values that we found here, the negative 2 plus y. Then we have a minus 3y plus 9, and now look at this. We have z in terms of just y. So let's simplify where we can. Z equals, distribute the minus 3 to both parts here, and we have a positive 6 and then a minus 3y. This minus 3y comes down, and we have plus a 9. Well, now let's combine our like terms. Z here, 6 and 9 become 15, and negative 3y minus 3y is a minus 6y. So now we have z in terms of y, and we have x in terms of y. Where can we go from here? Well, we want to have only really y by itself. So if we look here in the last equation, we can see we have z, we have x, y, and z, and we can plug in these values for z and for x in there, and we have an equation with only y. So let me do that over here. I'm going to rewrite that equation, the last one. So right here. Negative 4, and instead of x, I'm going to put this minus 2y, or minus 2 plus y, excuse me. Then we have plus a 5y plus z, our z value, which we found to be 15 minus 6y. And that's equal to 8. From there, we want to simplify. Distribute the negative 4 to both parts, and negative 4 times negative 2 is a positive 8, and negative 4 times y is a minus 4y. The 5y comes down, and then we have the 15 and the minus 6y here, equals 8. All right. Now let's combine our like terms from each side. Negative 4y plus 5y minus 6y comes out to be a negative 5y. 8 plus 15 is a 23, and that's equal to a positive 8. We subtract the 23 to both sides, and we have negative 5y equals 8 minus 23, which is a negative 15. Divide both sides by negative 5, and y equals a positive 3. We now have our y value. Well, now the rest of the work's pretty easy. We plug y in right here, and we get our x. So we have x equals negative 2 plus the y value we found, which was 3. And, well, negative 2 plus 3 is equal to a positive 1. So we got our x value here. Let's go find our z value. And z is equal to 15 minus 6y. So let's put that 3 in for this y here. And we simplify. Okay. Z equals 15 minus 6 times 3 is 18. And I'll put z here is equal to 15 minus 18, which is a negative 3. So we can write this as a coordinate point to be 1 for the x, 3y, and negative 3 for the z. And that is our final answer. X equals 1, y equals 3, and z equals negative 3. We're given this problem right here. X equals a negative 5y plus 4z plus 1. X minus 2y plus 3z equals 1, and 2x plus 3y minus z equals 2. And we need to solve this system by substitution. Well, first thing I'm going to do is I'm going to take my second equation, all right? And I'm going to put it over here, but I notice that my first equation has x already by itself. So I'm going to rewrite my second equation here, but instead of x, I'm going to put what we have for the first equation, negative 5y plus 4z plus 1. And then we have a then got sidetracked. So that's why this is difficult. This is my x value from the second equation. All right, so then we have a minus of 2y from the second equation plus 3z equals 1. And now we're actually going to simplify this where we can. Okay, negative 5y minus 2y is a negative 7y. 4z plus a 3z is a, well, 7z. 7. See, when I write 7s and z's here, again, lots of erasing this one, sorry about that. My 7s and z's, I always do a little thing in the middle, helps me organize it, and then sometimes confuses me. And then we have, well, just a plus 1 equals 1. Well, from here, all right, we want to, let's try to get y by itself. So I'm going to subtract a 1 to both sides, and we have negative 7y plus 7z equals, well, 0. 1 minus 1. Subtract 7z to both sides, means negative 7y equals a negative 7z. Divide both sides by a negative 7, and y is equal to z. All right? So that's what we have for y. Y and z are the same here. Okay, so now what we're going to do is take that information and we're going to go back to our first equation here. I'll write it down here. We have x equals a negative 5, and instead of y, I'll put a z. And then plus 4z plus 1. Now let's keep simplifying. Have x in terms of z. So x equals a negative 5z plus, well, 4z plus 1. Negative 5z plus 4z is a negative 1z. So x equals a negative z plus 1 here. All right, so we have x in terms of z, y in terms of z. Now we have to go kind of get our final little bit here. So we're going to take the last equation. I'm going to rewrite here, this one here, but instead of x, I'm putting my value in terms of z, negative z plus 1. And then we have plus 3, and instead of y, I put a z, minus z equals 2. Okay? So now we want to simplify this equation here and try, or solve it and try and get z by itself. Distribute the 2, and we have negative 2z plus 3, plus 2. Oof. I was adding the two values, and this video is all erasing. Plus 3z minus z equals 2. All right. Well, I want to subtract the 2 to both sides. Okay. So 2 minus 2 is, well, 0. And then from there, subtract 2 to both sides, and we get a 0 here. And then negative 2z plus 3z minus 1z is a 0z. So now I have a, well, 0z equals 0 and 0 equals 0. Something happened here. And what that's telling us here is that there is not one unique solution for this. So we have no unique solution for this system of equations. And that is it. That is our final answer. We're given this problem right here. A minus 2b plus c equals a negative 6. A plus 5c equals a negative 12, and negative a plus 6b plus 4c equals 3, and we need to solve the system by substitution. Well, first thing I want to do, I notice the second equation, I can quickly write that to have a by itself. And so by subtracting a 5c, I have a equals a negative 12 minus 5c. So just kind of note that to myself here, quickly, that I can get a by itself, and it's equal to negative 12 minus 5c. So now we're going to take that information with the first equation, and I'm going to put, well, instead of a, this negative 12 minus 5c in. So I have a negative 12 minus 5c from the second equation adapted, plug it in for a in the first equation. Then we have a minus 2b plus c equals a negative 6. So now let's simplify this, okay? Well, let's combine what we can with our like terms. If we add a 12 to both sides, okay, we add a 12 to both sides, what do we have? Well, a negative 6 plus 12 is a positive 6. Then I'll put b's first, negative 2b over here. And then negative 5c plus 1c is a negative 4c. Okay? Then from there, if I pull out a negative 2 from both parts here, negative 2, I'm left with a b plus a 2c. And that's equal to 6. Divide both sides by a negative 2, and I have b plus 2c equals a negative 3. Subtract 2c to both sides, and b is equal to negative 3 minus 2c. So now we have b in terms of c. Well, what we now can do is we're going to look at, again, our last equation, and we're going to plug in what we know for a as well as b here to get it just in terms of c and to simplify. So I'm going to fit that over here, my last equation. We have a negative, and then for the a, so we're using this one here, and then a, we have a negative 12 minus 5c plus 6 times b, which is what we just found, negative 3 minus 2c, plus 4c equals 3. And now let's simplify that. Distribute the negative sign to both parts, and we have positive 12 plus 5c. Then distribute the 6. We have, well, 6 times negative 3 is a minus 18. 6 times a negative 2c is a minus 12c. And then we add a 4c, and it's equal to 3. Alright, so now let's go combine our like terms. 5c and negative 12c and 4c all combine here to be a negative 3c. 12 and negative 18 add together to be a minus 6, and that's equal to positive 3. Add 6 to both sides, we have negative 3c equals, well, a 9. Divide both sides by negative 3, and c equals a negative 3. So we now have our c value. So we use this now to find, well, the other ones. So let's go find our b value, put negative 3 in for c. So b equals negative 3 minus 2 times a negative 3. Simplify that. Negative 3. Negative 2 times negative 3 is a positive 6. Oof. And then a little brain fart there. And negative 3 plus 6 is a positive 3. Gotcha. So we have positive 3 right there. So b is 3, c is negative 3, and let's go find our a. So let's rewrite what we have up here. A equals negative 12 minus 5, but instead of c, I'm putting a negative 3 that we found. Negative 12 plus, because negative 5 times negative 3 is a positive 15. And a equals, well, negative 12 plus 15 is a positive 3. So we can write all three of these as a coordinate point. We have 3, 3, negative 3, meaning that our final answer is a equals 3, b equals 3, and c equals negative 3. We're given this problem right here. Negative 2x plus 3y plus 5z equals negative 21. Negative 4z equals 20, and 6x minus 3y equals 0. And we want to solve this system by substitution. Well, I'm looking at my second equation right here. This one's actually pretty nice. So negative 4z equals 20 only has a variable z in it. So if I divide both sides by, well, negative 4, z is already by itself, and 20 divided by negative 4 is a negative 5. So we got one of the values very quickly. Well, where can we go from here? Well, we also know the third equation right here, okay, the 6x minus 3y equals 0. If I, well, add a 3y to both sides, I have 6x equals 3y. Well, divide both sides by 3, okay, divide both sides by 3, and we have 2x is equal to 1y. Or if we want to write like this, y equals 2x. So that was actually pretty easy to get y by itself as well. With both these informations, I take my first equation, negative 2x plus 3, and instead of y, I can put 2x in. Then we have plus 5, and instead of z, I put a negative 5 in. That's equal to negative 21. Now I have an equation with only one variable, which is x, and now I can, well, solve that equation here. Negative 2x comes down, 3 times 2x is a 6x, And 5 times negative 5 is a minus 25 and equals negative 21. I add a 25 to both sides and I get a positive 4. Negative 2x plus 6x is 4x. Divide both sides by 4 now, and x is by itself, and 4 divided by 4 is 1. So we have x equals 1, z equals negative 5. We got to find our y. Right here, super easy. Put 1 in for x. Y equals 2 times 1. And so what's your y value? Y equals 2. We can write this as a coordinate point as 1, 2, negative 5. And that's our final answer. X equals 1, y equals 2, and z equals negative 5. We're given this problem right here. 2x minus 4z equals 20. Negative 3x plus y minus 4z equals 20. And negative 4x plus 2y plus 3z equals a negative 15. And we want to solve this system by substitution. Well, first thing I want to do is, I see this first equation here. Let's go rewrite that down here. 2x minus 4z equals 20. If I pull out a 2 from both parts on the left-hand side, I'm left with x minus 2z equals 20. Divide 2 to both sides, and x minus 2z equals 10 now. Well, get x by itself, just add a 2z to both sides, and x equals 10 plus 2z. Not bad. Pretty easy to get x by itself. Well, I can use that information now with my second equation. So negative 3 here. But instead of x, I'm going to write in terms of z. 10 plus 2z. And then we have, well, just plus a y, minus 4z equals 20. So now I have an equation which is, well, z's and y's. Let's try to get, y by itself. That makes sense. Y by itself. Got lost my notes here. I want to get y by itself. So we distribute the negative 3 to both parts. So we have negative 30 minus 6z here plus y minus 4z equals 20. This should be fairly easy to get this one y by itself. Combine our like terms on each side. And well, negative 30 is the only thing that has to go over here. So we add a 30 to both sides and we actually get a 50. Negative 6z and minus 4z is a negative 10z, and then we have plus the y comes down. Add a 10z to both sides, and now y is by itself, and it's 50 plus 10z. Not bad. So we have x by itself and y by itself, and each one is in terms of z. We're on our way. Now, we have to look at the last equation here. Okay, this one's tricky. We're going to rewrite this last equation. 4 instead of x, or negative 4 instead of x, we're putting a 10 plus a 2z that we found earlier. Then we have plus a 2. Instead of y, we just found that's 50 plus 10z. Then we had a, well, just 3z left over, and equal to negative 15. No, that fits. I think it fits, yeah. It should fit. And now we want to solve this one for z. It's the only variable there, so we should be able to. Negative 4 distributes, so we have negative 40 here, minus an 8z, plus distribute the 2 to both parts, plus 100, plus a 20z, and then we plus 3z equals negative 15. Let's combine our like terms where we can. Okay, well, we have negative 8z plus 20z plus 3z comes out to be a 15z. Negative 40 plus 100 is a positive 60 equals negative 15. Subtract 60 to both sides. 15z equals a negative 15 minus 60 is a negative 75. Divide both sides by 15, and z equals a negative 5. After all that, we got our z value, but the rest is pretty easy to get now. We take that z value, let's plug it in for this z, to get y by itself. 50 plus 10 times a negative 5. 50, 10 plus negative 5 is, well, that's a negative 50. And 50 minus 50 is 0. Same thing, take that negative 5, put it in for this z. So we have x equals 10 plus 2 times a negative 5. 2 times the negative 5 is, well, a negative 10. X equals 10 minus 10, and you can see where this is going. 10 minus 10 is 0, so I'll put it here, x equals 0. So we got a lot of zeros in this one. We can write this as a coordinate point of 0, 0, negative 5, and that's our final answer. X is 0, y is 0, and z is negative 5. We're given this problem right here. X plus 3y equals negative 17. 3x equals a negative 6. And 4x minus 3y plus 6z equals 25. We want to solve this by substitution. First thing that pops out to me here is the second equation. 3x equals negative 6. If I divide 3 to both sides, very quickly get x by itself, and negative 6 divided by 3 is a negative 2. So we got one of the values very quickly, which is great. Well, we can take that actually with the first equation. And instead of x, we're going to put a negative 2 in. And now we have plus 3y equals negative 17. And look at that. We have an equation already with just y as the only variable. Simplify this, add a 2 to both sides. 3y equals, well, negative 15. Divide both sides by 3, and y equals negative 5. And quickly, we got two values. So let's just go find our z value, which is just in the last equation. So we're going to rewrite that last equation right here. But instead of x, we're going to put a negative 2. So 4 times negative 2 minus 3. And instead of y, put a negative 5. Plus 6z equals a 25. And now we're just going to solve for z. It's the only variable here. 4 times negative 2 is a negative 8. Negative 3 times negative 5 is a positive 15. Plus 6z equals 25. Negative 8 plus 15 is a positive 7. Plus 6z equals 25. Subtract 7 to both sides. 6z equals 25 minus 7, which is 18. And, well, 18 divided by 6 is a positive 3. So we can put these three values as a coordinate point. Negative 2, negative 5, and 3. And that's it. Very quickly, actually, we got our answer, final answer of x equals negative 2, y equals negative 5, and z equals 3. We're given this problem right here. 5r plus 4s minus 6t equals a negative 24. Negative 2s plus 2t equals 0. And s minus t equals 2. And we want to solve this system by substitution. Well, what do we do first? Let's look at our second equation right here. Negative 2s plus 2t equals 0. Well, I want to get, well, what I'm going to go for, I'm trying to get t by itself here. So if I add a 2s to both sides, I have 2t equals a 2s. Then from there, divide 2 to both sides, and, well, t just equals s. Not too bad. Okay, that happens. So now let's use, well, this equation. Let's substitute s in for t. So we have s minus t equals 2. I'm going to take this s and plug it in for that t. I have s now minus s is equal to 2. And what's a variable subtracted by itself? 0. So 0 equals 2. Well, that's weird. Can 0 equal 2? No. So we have an error here. What does that tell us? That tells us that we have no unique solution to the system of equations. So that's our final answer. No unique solution. We're given this problem right here. Negative 5r plus 5s plus 3t equals a negative 23. Negative 5r plus 3s minus 3t equals negative 11. And negative 6r plus 6t equals a negative 12. And we want to solve the system by substitution. Well, first thing I'm looking at is, well, this last equation. If I pull out, we'll rewrite it here. Negative 6r plus 6t equals a negative 12. If I pull out a negative 6, I am left with a positive r minus a t, and that's equal to negative 12 here. Divide both sides by negative 6, and we're left with r minus t equals, well, negative 12 divided by negative 6 is a positive 2. Add a t to both sides, and r equals 2 plus t. And so right off the bat, it looks like it's going to be an easy problem, but it's not. Let's be honest here. Okay? So what we're now going to look at here is the second equation. Okay, I'm going to take this value of 2 plus t and I'm going to plug it in for r. So we have negative 5, and then instead of r, I have a 2 plus t, then plus 3s, and then minus 3t equals a negative 11. And now we're going to simplify this as much as we can. Let's try to get s by itself. So distribute the negative 5 over, and we have negative 10 minus 5t. Then we have plus a 3s minus 3t equals a negative 11. Let's combine our like terms where we can. Well, negative 5t and a minus 3t is a negative 8t. We have, well, just a 3s here. And then if we add a 10 to both sides, negative 11 plus 10 is a negative 1. To get s by itself, I'm going to add an 8t to both sides, and so we have 3s equals a negative 1 plus 8t. Divide both sides by 3, and s equals negative 1 plus 8t over 3. Fantastic. But it's a little difficult with a fraction. But don't be afraid. Same process still applies. We're now going to look at our first equation here. And we're going to plug in what we know for r and s for the variables, and we'll get t by itself. So let's rewrite that. Put a line here. We have negative 5, and instead of r, I have 2 plus t. Let's make sure I can get it to fit. Then we have the top one, 5, right here, right? 5 plus 5. Instead of s, I have a negative 1 plus 8t over 3. Then we have plus 3t equals a negative 23. Got to fit. So now I want to simplify this. Let's take our time. Distribute the minus 5. Negative 10 minus 5t here, plus, let's distribute that 5 to both parts again. Okay, put a big fraction. We have minus 5 going to both parts of the numerator, plus 8 times 5 is 40. We have 40t all over 3, plus 3t equals a negative 23. All right. Well, let's go add a 10 to both sides here. And then we're going to combine minus 5t and 3t. So negative 5t plus 3t is a negative 2t. Plus, bring this down here again, negative 5 plus 40t over 3. And that's equal to, add a 10 to both sides here, and we have a negative 13. Well, I want to get 3 out of this denominator here, but I want to keep my t's on the left-hand side. So what I'm going to do is multiply both sides here by 3. In doing so, this is what happens. 3 times negative 2t is a negative 6t. Plus 3 multiplied by this fraction cancels out the 3 in the denominator. So we're left with just the numerator of negative 5 plus 40t. Be careful with that step right there. That 3 will cancel out with this 3 down here. So we just bring down the numerator. And then negative 13 times 3 is a negative 39. From there, we're almost home. We can add the negative 6t and 40t to be a positive 34t. And then add a 5 to both sides. So negative 39 plus 5 is a negative 34. Oh, isn't that nice? Divide both sides by 34. T is by itself, and negative 34 divided by a positive 34, negative 1. After all that fraction work, we got t equals negative 1. So now the rest is fairly easy. Let's put that negative 1 in for this t value here. S equals negative 1 plus 8 times a negative 1 over 3. Simplify that. S equals, well, 8 times negative 1 is a negative 8, plus a negative 1 is a negative 9, divided by 3. And S equals negative 9 divided by 3, a negative 3. Oops, well, that's negative 3. Same thing here, put negative 1 for this t. R equals 2 plus a negative 1. And we can write that here. R equals, what's 2 plus a negative 1? And that is a positive 1. So we can write this as a coordinate point solution of 1, negative 3, in the order they gave to us, the variables, negative 1. And that is our final answer. R equals 1, S equals negative 3, and T equals a negative 1. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math, when you need help you use Minute Math.